Welcome back to the Deep Dive.
Good to be here.
So today we're digging into a pretty significant proposal floating around the Ethereum space.
Yeah, this idea from Vitalik Buterin about maybe, just maybe, replacing the EVM.
Exactly, the Ethereum virtual machine, swapping it out potentially for RISC-V. We've looked at the forum posts, the analyses, the why, the pros, the cons, and this nervous CKB example that keeps coming up.
Right, they're already using it.
So our mission, as always, is to unpack this. Why now? What could it actually mean for Ethereum?
Well, it kind of boils down to scaling, especially layer 2 scaling. Think ZK rollups.
Okay, the tech that's supposed to make Ethereum faster and cheaper.
Exactly. But right now, making the current EVM work efficiently with ZK proofs is tricky. It's slow.
How slow are we talking?
It's like there's this translation overhead. The EVM bytecode often gets translated in something more ZK friendly internally, which, guess what? Often looks a lot like RISC-V.
Ah, okay, so you're doing the work twice, almost.
Pretty much. And that translation step, it can apparently increase proof times by like up to 800 times in some cases.
800 times, wow.
Yeah, and even just proving the basic EVM operations themselves can eat up, maybe half the prover's effort.
So that's a major drag on performance and cost for these L2s.
It's a huge bottleneck for that whole roll-up-centric future Ethereum's aiming for. And that's the core motivation behind Vitalik's post back in, April, suggesting RISC-V long-term.
Right, and just to be super clear, this isn't about changing, how accounts work or where data is stored.
No, not the fundamental concepts. It's purely about the engine under the hood that runs the smart contract logic.
So the idea is new contracts would target RISC-V directly.
That's the long-term vision, yeah. Compilers point to RISC-V instead of EVM bytecode and the old EVM instructions. They'd effectively become like system calls within that RISC-V environment.
Okay, upgrading the engine, basically. So what are the hoped-for benefits, the big wins?
Number one is ZK proof efficiency. Massive gains. We're talking maybe 50x, 100x faster, maybe even more.
Which means for users.
Faster finality on layer 2, and crucially lower transaction fees. Much lower.
Okay, that's a big deal. What else?
Well, potentially simplifying the core Ethereum execution layer itself. The EVM has some, let's call it technical debt. Things like self-destruct that are hard to manage or remove. RISC-V is seen as maybe cleaner, easier to maintain, easier to upgrade down the line. Plus, it handles smaller numbers, common in programming, more naturally than the EVM's fixed 256-bit size.
And I think you mentioned broader tool support, because RSVV is open.
Exactly. It's an open standard, not proprietary. So, theoretically, you get access to a wider range of existing development tools, compilers, maybe even more programming languages becoming viable on Ethereum, more flexibility.
Okay, sounds good on paper, but how on earth would you actually do this? It sounds like replacing the foundations.
Yeah, it's a massive undertaking. Vitalik outlined a few potential strategies, and the key theme for all of them is backward compatibility. You can't break existing contracts.
Right, that would be chaos.
Total chaos. So one idea is dual VM support. Run EVM contracts and new RISC-V contracts side by side, somehow making them talk to each other.
Okay.
Another is maybe building a RISC-V based interpreter for the EVM. So existing EVM contracts run, but they're actually being executed by this RISC-V layer underneath.
Kind of wrapping the old engine inside the new one?
Sort of, yeah. And then there's a more abstract idea of just formalizing support for different VMs where EVM on RISC-V is just the first example.
But these are all huge engineering lists, presumably. What are the worries, the pushback?
Oh, yeah. The scale of the work is immense. New tool chains, new compilers, new auditing practices. Everything needs rebuilding or adapting.
And is the tech, like ZK-RACV, actually ready for prime time? Secure, audited?
That's a major question. Maturity and security are big concerns. Plus, there's debate, should Ethereum be focusing its energy on making L1 itself faster with RISC-V or double down entirely on the L2-centric roadmap? Is this a distraction?
So still very much an exploratory idea.
Definitely. It's meant to spark long-term thinking.
Got it.
Yeah.
Okay, maybe step back a sec. What is RISC-V, fundamentally?
Right. It's an instruction set architecture, or ISA. Think of it as the basic language a computer processor understands, but unlike, say, ARM or by86, which are proprietary, RISC-V is open source. It's a standard anyone can use, inspect, and build upon. It's designed to be simple, modular, and extensible.
And why is that good for blockchain specifically?
Well, the openness is great for security audits, transparency, Modularity means you could potentially customize it, maybe add special instructions for cryptography. It's generally efficient, potentially lower power use, and there's a growing ecosystem around it, tools, developers. Plus, being adaptable means it might handle future tech changes better.
Which brings us back to Nervos CKB. They're the real-world test case here.
Kinda, yeah. Nervos is a layer 1 blockchain, and its virtual machine, CKB VM, runs on RISC-V, specifically a profile called RI64IMSC. They deliberately excluded things like hardware floating point to keep it deterministic and simpler for the blockchain context.
And developers just write code for this RISC-V machine.
Yep. And interestingly, CKB VM uses a standard file format, ELF, the same one Linux uses. So developers can often use standard tools like GCC or LLVM compilers they might already know.
Oh, interesting.
Yeah, and interaction with the blockchain happens via system calls, similar to how programs ask the operating system to do things. They also support dynamic linking, which helps reuse code between contracts.
What's their philosophy behind using RISC-V?
Flexibility and future-proofing seem key. Especially around cryptography, they talk about cryptographic agility. Meaning, developers can pretty much implement any cryptographic algorithm they want as a RISC-V program on CKB without needing a whole network upgrade or protocol change. If a new signature scheme comes out, you can just deploy it.
Ah, okay. That avoids waiting for core devs to add support.
Yeah.
Talik mentioned them specifically, right?
He did, yeah. Explicitly cited Nervos CKB as a precedent, showing this isn't just theory.
So what kind of applications does this flexibility enable on Nervos today?
Well, the crypto agility is one thing. They support different signature types, hash functions. They have things like account abstraction. JoyID uses WebAuthn, for instance. There's cross-chain identity stuff like .bit. And they're building bridges to Bitcoin, too, this BTCKB initiative.
So it's quite mature. It's been running since 2019.
The CKB VM itself, yes, it's battle-tested, gone through upgrades. But like any tech, there are ongoing challenges. Performance optimizations are still happening, and educating developers on their unique model takes time.
Okay, so wrapping this up, it feels like the core tension is massive potential upside for Ethereum scalability and flexibility with RISC-V.
Right, huge potential gains.
Versus the absolutely enormous effort and risk involved in making such a fundamental change.
Exactly. It's a monumental task. But Vitalik's proposal shows they're willing to think radically about long-term challenges, and it underscores that layer 1 efficiency still matters. And Nervos provides, real data points on what our RISC-V chain looks like in practice.
Definitely food for thought. If Ethereum could make L2s dramatically faster and cheaper via RISC-V, how does that reshape the dApp landscape? What kind of new applications become possible if the execution environment is more flexible? Something to chew on.
For sure. It opens up interesting possibilities.
All right. Thanks for diving deep with us on this one.